All right, guys, we're going to go on and finish the review sheet today. I believe we stopped at number 21. 45x squared minus 150xy plus 125y. Is there a greatest common factor between these three terms? So we have 5 and y. If we take 5 out of 45, we're left with 9x squared. The y factors out completely. Minus x. Because 5 into 15 is 3. We can put the 0 back. X plus 25. So, any questions on this so far? Two sets of parentheses with 3 spaces. Now we can find the sign. Since the third term is positive, the signs are the same and match the sign of the middle term. So minus and minus. Factors of 9x squared, well, we'll have x and x. So we do 3 and 3 because the factors of 9 are 1 and 9 or 3 and 3. Factors of 25, 1 and 25 or 5 and 5. Which one do we want to try first? 5 and 5. At this point here, we can check and see if we get the correct middle term. 3x times negative 5 is negative 15x. Negative 5 times 3x is negative 15x. And negative 15x minus 50x is negative 30x, which is the middle term we wanted. So this here is our answer. Let's get a different color. Now, if we wanted to, we could rewrite this as 5y times 3x minus 5 squared. Because since both factors are 3x minus 5, we could write it as a single term squared. We don't have to, but it is a way to simplify it. Questions on these here? We ready for the next one? So the next one we're going to look at is this one here. So we have 31,250 x cubed y minus 93,312 y. Well, y goes into it for sure. So we can take 31,250 and divide it by, so what do we say a possible factor is? 3. 31,250 divided by 2 is?
Try 4. I got it.
1,250 divided by 4. So 2. And if we divide 31,250 by 2, we get, well, 1565 x cubed minus, we can do the same thing with 93,312 which should be 46,656.
Oh, it didn't have some at the first.
Yep. There you go.
Oh, thank you.
So 2, because since they're both even, they are both divisible by 2. Now we can see if we can take the cubed root of our new number, 15,625, is 25. We can also take the cubed root of our 46,656, which is 36. So our cubed root of 15,625x cubed is 25x. And our cubed root of 46,656 is 36. Because once we see the pattern, it's hard not to see it. It's one of those things, once you see it, you can't unsee it. Our signs are going to be the same, opposite, always end on a positive note. So negative, positive, positive. Our first term is 25x, and the bigger one will have 25x squared. Then we'll have 25x for the first, and then we won't have a 25x term. Our other term is 36. The first spot it'll show up is in the middle, which will just be 36 of the first. And our last one is 36 squared. Now when simplifying, the 2y times 25x minus 36 doesn't simplify. That's already as simplified as it gets. The first one we need to simplify is our 25x squared. So really we're multiplying it by itself, 25x times 25. Our 25 times 25, 625. And our x times x is x squared. The next one we're going to do is 25x times 36. And our 25 times 36 is 900x. And our last one is going to be 36 squared, which is
1296.
I was trying to do it in my head, but he was writing it too fast. I was trying to cross multiply. Or like, just carry my number. But I was trying to add it.
yes.
So how do you know that?
I was really, that's
Huh?
and I was trying to
How
go
did you like first grade?
He gave me like 5 seconds.
You know how it's just 3 spaces or like this one? Not that one. Crap. Where'd it go? Yeah, this one. Like this one, how there's just 2 and there's 3 spaces. How do we know that we need 3 and then 5 spaces?
What's our power?
What do you mean?
What's the exponent
3 times 7.
attached to the variable?
No, wait. Bro,
Wait,
it's
what?
28.
So for this one here, what's the variable? Because we have y, yes? So we factored it out. What's our remaining variable we have to the third? So we're looking at a sum or difference of perfect cubes.
No.
So that defines it as a sum or difference of perfect cubes. That's why we're doing the 3 and 5, because it follows that setup. Because when we have 3 terms and the biggest one's x squared, okay, we're going to factor it like we normally do. Because this sum and difference of perfect cubes, sum and difference of perfect squares kind of have a set pattern to them. The rest kind of follow our other method. Because that's why, like on the previous one, we did 2 sets of parentheses with 3 spaces. Because 3 terms, it's a quadratic, we're solving it that way. This, our cubic, 3 and 5. And even though our numbers were big, it followed the same path as all the rest. Let's look at 23. 8x cubed minus 6y, or 64y cubed. X cubed, y cubed. This is another sum or difference of perfect cubes. Is there a greatest common factor between these two terms?
Eight.
2 and 4 are common factors, but 8
Great.
is the greatest common factor.
8 times.
Yeah.
Yes.
GCF is 8, so we can factor 8 out to both.
She can do whatever she put her mind to.
So the cubed root of x to the third is x. Cubed root of 8 is 2,
2y.
and our cubed root of y to the third is y. Let's go with this. Our signs are going to be the same. Opposite always end on a positive note. So the same would be minus. Opposite would be plus. Always end on a positive note would be plus. First one is x, and then we would have,
X squared.
and then x to the first. Our other term is, middle would be 2y, 2y squared. And our final answer, when we simplify, we'd have 8 times x minus 2y. Our x squared would just be, well, x squared plus x times 2y is 2xy. And 2y squared would be 4y squared, because because when we square it, we're saying we're multiplying it by itself. So our 2y times 2y would be 4y squared.
That's straight here. These are pretty easy now. I thought we could take this.
We ready for 24? Greatest common factor.
Oh,
A, B,
there's B,
and
there's A squared, actually.
Because our a, we have a cubed, a to the first, a squared. So it's just going to be a. Our b, we have b squared, b cubed, b to the fourth. We can do b squared. And c is only shows up in one of them. Now we should look at 186, 9, and 117. If they're going to share a common factor, well, they would have to be the factors of 9. Well, the only factors of 9 are 1, 3, and 9. So I can take 186 and divide it by 3. And 186 divided by 9, 9's out. So 117 divided by 3 is?
All I do is go 39. Oh, no, I didn't.
So our greatest common factor for this here is 3ab squared. Because if we know a factor that works for 2 of them, we can try it with the third, and if it works, then it is a common factor. If it doesn't work with all 3, it's out. So the first thing we can do is divide 186 by 3, which is 62. If we remove an a from a cubed, we're left with a squared, and the b squared factors out completely. Minus factor of 3 out of 9, we're left with 3. So the a factors out completely because we remove 1a and there's only 1 there, so it's gone. We remove b squared from b to the third. We remove 2 away from the 3, leaving us with 1. C stays there. Plus 39. A squared becomes a b squared. Now, looking at this here, I mean, we could go and see if it's possible to factor this. But one of the reasons that this is not factorable at this point, it's not factorable mainly because we have C. We have a C term in the middle. We have just, there's too many variables inside our set of parentheses for this to factor. If it had been 62a squared minus 3ab plus 39b squared, then there's a chance it could factor. But here C and our other terms kind of throw everything off. Yeah, there's too many variables and they don't have the right kind of function with it. And especially the C that doesn't show up anywhere but the middle kind of throws everything off. Because it is possible to factor with multiple variables, but we need, especially like our sum or difference of perfect cubes, this here, or x squared x, no x term. No y squared, that kind of up and down. Because we need a squared, we need a here, no a term here. No b, we need a b with our a, and then b squared. We kind of need that up and down. Questions on 24? 25 and 26 are factoring by grouping. They're not on the test.
Oh, let's go. So we're going straight to 27. That's what's up.
27 and 28. 27. Again, we should always start with greatest common factor. What's our greatest common factor?
12. I got 12 times 12, 12 times 12.
Yes.
I like the song. It was like 12
12 times 12 is the only 12 times table times.
Is there any other greatest common factor between these two terms?
X squared.
What is it? It has to be 12.
Never answered.
Oh, x squared, you're right.
Because 12 is the greatest common factor between 12 and 144. And since they both have an x, we can factor out x squared. Now for our 12x cubed, when we factor 12x squared out, the 12 factors out completely. And when we factor out x squared from x cubed, we're left with x minus
12.
We factor 12 out of 144, we're left with 12. And the x squared factors out completely. And that's it.
Are we starting the test tomorrow?
Because we'll start and finish it tomorrow. Because there's 20 factoring problems, and y'all should get them all done in that one day. I think the only reason that you don't get them done is, I don't think for my belief is that if you're not able to get them done in that day, 2 days is not going to help. Because all that would mean is you're going back over resetting and then trying them again. At this point, I believe y'all are ready for these, and y'all will be fine. Because there's 3 of problems like these 2 here. Because if we look at the next one, the greatest common factor between 15x squared and 30x is 15 and x. So if we factor 15x out of 15x squared, we're left with because our 30 divided by 15 would be 2. Because the x with our 30x would be factored out. And again, just as a reminder, if a term factors out completely, it reduces to 1. Questions on any of this here? This is the last one we'll look at. and this is kind of extending on from what we've been doing, because even though our variables are now x to the fourth and x squared, it still works the exact same way. Because we can look for a greatest common factor, but 1, 32, 256, there's not a greatest common factor between all three. Our signs. Since the third term is positive, our signs are the same and match the sign of the middle term. Negative and negative. Our factors for this here. So x to the fourth would indeed be x squared and x squared. Because in our normal ones, we had x squared for the first, so we had x and x, which kind of matched to the middle term. Here, our first one's x to the fourth. The middle term's x squared, so we have x squared and x squared. Now, factors of 256. 1 and 256. 2 and 128. 3 does not work, but 4 and 32. Or not 32. Make sure. Because 16 and 16. 8 is 32. 4 is 64. That's actually it. Which set of factors do we want to try first?
Let's go with
And we can check this here. X squared times negative 16 is negative 16x squared. Negative 16 times x squared is negative 16x squared. Negative 16x squared minus 16x squared is negative 32x squared. Is that the middle term we wanted? Questions on this here? And all the ones we factored up to this point, kind of the x and x was to the first power, yes? And whenever we do have that first degree, we're done. Here, what's the exponent with both of our x's? 2, yes? Let's look at the first one, x squared minus 16. 2 terms being subtracted, yes? There's a chance that is a difference of perfect squares, yes? Is x squared a perfect square? Is 16 a perfect square? What times, is there something times itself that gives us 16? So is x squared minus 16 a difference of perfect squares? So that means this here is factorable.
oh boy.
Because our difference of perfect squares, the signs were opposite. We would have x and x, 4 and 4. Because x squared minus 16 would factor to x plus 4 and x minus 4. What does that mean about our other one? So our expression x to the fourth minus 32x plus 256 actually factors to x plus 4 times x minus 4 times x plus 4 times x minus 4. So it's the exact same thing we've been doing, it's just we had to do one more step between it. Questions on this here? And that